In this video on the Fundamentals of Math 084, we're going to talk about graphing solutions to inequalities. We're going to be using a lot of what we already know about graphing lines in the plane. So if you are uncertain about how to graph a line in the plane, you should go back and watch the video on graphing lines first. So let's get started. Let's graph the collection of solutions to this inequality. 6x minus 2y is less than 8. Inequalities, just like lines, are easiest to graph if they are in slope-intercept form. So just like if we were going to graph a line, let's put this into slope-intercept form, so let's solve for y. We'll start by getting the x's to the other side, so subtract 6x from both sides. And we get minus 2y is less than minus 6x plus 8. And then divide both sides by minus 2. On the left we end up with y. On the right we end up with, let's see, negative 6x over negative 2 is positive 3x. And then 8 over negative 2 is negative 4. And remember, when you divide or multiply an inequality by a negative number, the inequality symbol in the middle turns around. So we used to have less than, we're going to end up with greater than. So the inequality we're going to graph is y is greater than 3x minus 4. Now this looks almost like the equation of a line, except it's not actually an equation. There isn't an equals in the middle. But the line that we would get from this, y equals 3x minus 4, this line actually splits the coordinate plane into the half that we want and the half that we don't want. So we will need to start by graphing this line. The y-intercept of this line is negative 4, so that's down here. And then the slope for this line is 3, so we can go over 1 and up 3. Over 1 and up 3, over 1 and up 3. And so our line is going to be the line through these points. Now I'm going to hold off on actually drawing that line just for a second. Our inequality is what's called a strict inequality. It's not or equal to. It is just greater than. So the line through these points is where the two sides of the inequality are equal to each other. But we want points where one side is bigger than the other, not where they're equal. So the line through these points doesn't itself consist of solutions to the inequality. We need some way to indicate that this line is splitting the plane in half, but we're not including the line itself. And the way that we do that is by drawing a dotted line. So here's the dotted line through those points. And this line splits the plane into the half that we want and the half that we don't want. But the question is, which half is which? Do we want the half above or the half below the line? For that, just take another look at this inequality. The y here, remember y coordinate really tells you height in the plane. And this part here, 3x minus 4, this is sort of playing the role of the line. So what this inequality says is that we want our height to be greater than the line. And that means above the line. So we want the side of the plane that is above the line. So that's this side. Okay. So the collection of solutions to this inequality is all of the points above this red dotted line. So everything in the blue half plane that I've sketched here. Okay. Let's do another example that's a little bit different. Same flavor though, same general idea. So let's graph the collection of solutions to this inequality. Oops, I wanted this one to be like that. There we go. So 2x plus 3y is less than or equal to 9. We'll start in the same way. We'll solve for y first. Minus 2x minus 2x. We get 3y is less than or equal to negative 2x plus 9. Now we'll divide both sides by 3. On the left-hand side, we get y. The inequality this time will not turn around because we didn't divide by a negative. We divided by a positive. So we will leave the inequality less than or equal to. And then on the right side, negative 2/3 x plus 3. All right, so let's go ahead and graph this. We'll start by pretending this is the equation of a line, and we'll graph that line. So the y-intercept is 3, so that's here. And then we'll move according to the slope. So that's right 3, 1, 2, 3, and down 2. Down because the slope is negative. 1, 2. Right 3, down 2. Right 3, down 2, and so on. Okay, now unlike in the previous example, this inequality is or equal to. It is not a strict inequality. So that means points on the line where the two sides of this are the same, those points will be solutions because the inequality says or equal to is good enough. So we need some way to indicate that points on the line are included in our collection of solutions. And to do that, we'll use a solid line. So like this. I decided to use blue this time because it seems like we're using blue for the collection of solutions. This time the line itself does consist of solutions, so we'll use blue. Now we need to decide which side of the line is the half plane that we want. And looking back at the inequality again, we have y, which is the height, is less than or equal to the line. So we want our height to be under the line, so that is the lower half plane. So that's this side here. All right, so there's the collection of solutions to 2x plus 3y is less than or equal to 9.